Alright, so in this video we're going to learn some basics of trigonometry by using our trigonometric ratios. So now what exactly is trigonometry? It is simply the study of angle measurement. And so in this video we're going to learn our trigonometric ratios that we use to find the acute angles, or the ratio of the acute angles of a right triangle. Alright, so here we have a right triangle, and here are our trig ratios: sine, cosine, and tangent. All right, so sine, if we're looking at an angle, the sine of that angle, or the ratio, would be the side that is opposite that angle over the hypotenuse of that triangle. Cosine would be the side that is adjacent to that particular angle over the hypotenuse of the triangle. And tangent would be the side that is opposite that angle over the adjacent side to that angle that we're looking at. All right. The acronym that we normally use is right here. It's called SOHCAHTOA. Sounds very weird, but it works. So S-O-H, the S stands for sine, and that is opposite over hypotenuse. All right. Cosine, for the C, adjacent over hypotenuse. And tangent, TOA, opposite over adjacent. All right, so sounds a little weird at first. The more you use it, the more you remember these trigonometric ratios. All right, so we have this example here of this right triangle, and we want to find the sine, cosine, and tangent of angles A and C. We're not using angle B because right here, the trig ratios only refer to the acute angles, so we don't use that right angle there. All right, so let's try this problem here, or find the ratios. So we want to find the sine of A. All right, so this is angle A right here. Sine is opposite over hypotenuse, so that ratio would be opposite would be 5 over hypotenuse would be 13. And that is already in simplest form. We cannot simplify that 5 over 13. So the trig ratio for sine of A is simply 5 over 13. And remember how to locate the hypotenuse. It is always opposite the right angle. All right. So now let's look at this one. Cosine of angle A. So cosine is adjacent over hypotenuse. Remember, adjacent is the side that is next to it. So that would be 12 over the hypotenuse. That would be 13. And so you may ask, okay, isn't the hypotenuse adjacent to angle A? Yes, it is, but when we're looking at the adjacent side, we're only looking at the legs of the triangle and not the hypotenuse. All right. All right, so let's look at tangent of A. Tangent is opposite over adjacent. So the side that is opposite angle A is 5 over adjacent would be 12. So those are my trigonometric ratios for angle A. I would reduce them if I could, but I cannot reduce any of these numbers. All right. So next, let's look at angle C. So sine of C, again, opposite over hypotenuse. So my opposite side for C would be 12. My hypotenuse would be 13. So that ratio is 12 over 13. Cosine of C. Cosine is adjacent or next to, so that will be 5 over hypotenuse. Hypotenuse of this triangle is 13. And then last, we have our tangent of C, and that would be opposite. That would be 12 over adjacent. Adjacent would be 5. All right. So we found our trigonometric ratios for the acute angles of this triangle. All right, so let's try another problem here. We want to find the trigonometric ratios of the acute angles of this triangle. All right. So now when we look at this triangle here, we notice that we have a side here that is 9, 12, but our hypotenuse, and again, we know that's the hypotenuse because it's opposite the right angle. We don't know the length of that side. So how do we find the length of the third side? Well, since this is a right triangle, if you have two sides, remember that you can always use the Pythagorean Theorem. And if you're not familiar with the Pythagorean Theorem, please see my video, the Pythagorean Theorem and its converse. And the Pythagorean Theorem is basically, or it is, the formula a squared plus b squared equals c squared. A and B are your legs. C is the hypotenuse. And so we want to, if we have two sides, we can use this formula to find that third side there. So in this case, we want to find C, which is the hypotenuse. So I'm simply going to plug in 9 and 12 into the Pythagorean Theorem. All right. So A and B are interchangeable. So I'm going to say 9 is A, 12 is B, and C would be my hypotenuse. Don't know what it is. And I could actually flip this. It doesn't matter. I'm going to get the same answer. All right. 9 squared is 81 plus 144 because that is 12 squared equals C squared. 81 plus 144. Do it quickly. 225 C squared. All right. And then to get rid of that 2, remember we take the square roots. And so C is 15. So this side here is 15. So whenever you're trying to find your trig ratios and you don't have that third side, it's going to be a right triangle. So you can always use the Pythagorean Theorem. All right. So let's go ahead and find our ratios here. Okay. So the sine of W, cosine and tangent of W. So sine, opposite over hypotenuse. Opposite 12, hypotenuse 15. Cosine, adjacent over hypotenuse. Adjacent would be 9, and the hypotenuse is 15. Tangent of W, opposite, which is 12, over adjacent, which is 9. We can reduce these. We always want to reduce our ratios. So I can reduce 12 over 15. They're both divisible by 3. So that's 4/5. 9 over 15. That would be 3/5. 12 over 9. That would be 4/3. So I've simply just reduced the fractions there. All right. And so now let's find the sine, cosine, and tangent of x. Sine, opposite over hypotenuse, 9 over 15. Go ahead and reduce that, 3/5. Cosine of x, adjacent over hypotenuse. Adjacent is 12, hypotenuse is 15. I'm going to go ahead and reduce 4/5. And tangent of x, opposite over adjacent, 9 over 12. And that would be 3/4. All right. So we found the trig ratios of our acute angles of this triangle. Remember, you can use Pythagorean Theorem if you need to find that third side. Okay, so for our last problem here, I would actually like for you to try this problem on your own. You have a right triangle here with side lengths of 16 and 34, and you want to find the sine, cosine, and tangent of angles L and M. So go ahead and pause the video and try this problem on your own. All right, so here are the answers to the problem I wanted you to try. If you notice here, you were missing a leg, and so you had to use the Pythagorean Theorem to find the missing leg in this case, and you should have gotten 30. All right, your answer should have been 15 over 17, 8 over 17, 15 over 8, 8 over 17, 15 over 17, and 8 over 15 after reducing the fractions. So hopefully you got it correct. If you did not get it correct, I suggest you pause the video, analyze this problem a little bit more to make sure you understand trigonometric ratios. All right. So we reached the end of our lesson, and I want to thank you for learning with me.